Hi there. In this video I'm going to show you how I bought the wrong fan for the job and hopefully somehow fix the problem. So I need some ventilation in the attic. It's getting quite hot in the summer, so I thought about it, found some I don't know, brand solutions, but none of them actually was I don't know, moving enough air to cool down the attic. So I decided I can buy a solar panel, I don't know, a 15-watt solar panel, something like that, which will output a maximum of about 22 volts, the ones that I found at least. And that means I can use that with a 24 volt fan. Now I looked online, the fan, a decent 24 volt fan was about $12–13, something like that. So went to the flea market or whatever it's called, the market with old stuff, just to have a look around, and actually, 24 volt fan. Interesting, isn't it? Gave the model number a search, didn't find one with HR, only this first part, minus this, and it said working from 10 to 24 volts, which is perfectly fitting my needs. Looked at this one, saw that it had more than 2 wires. The one that I found without HR had only 2 wires, and thought, this must be some kind of PWM fan, but those also work in DC mode, so raising and lowering the voltage, most of them at least. So I bought 2 of these for $7 or something like that, so about half the price of a new one, or $6 even, whatever. The problem is, I came home, connected a power supply to it. Let me connect it again and show you. Excuse the weird angle, I'm trying to also capture the fan right here in the corner and this power supply at the same time. So connected black and yellow, like most at least computer 12 volt fans need to be connected. And that's not how a fan spins, is it? Decided to, actually tried with more than 1 voltage and whatnot, so went to 24 volts, does the same thing. Decided to open one of them up and have a look inside. Inside, quite a lot of dust, so they were in a really dusty environment, but overall the bearings were still decent, no issues that I could see. But here is where the fun begins. So my black wire comes here and it's going directly to the windings of the motor. This is a brushless motor, just to mention that. My yellow wire comes here and goes directly to the other end of the windings. So there's a single coil in here. All of the wires are basically in series. Yeah, that doesn't sound good, does it? And the other 3 colored wires, blue, white and red, well, those come to this Hall effect sensor, that tiny guy right there, which I was not able to find online. So it's an, I don't know, I think an I'm not seeing through the camera properly. Anyway, I managed to see it with my eyes and searched for it online. Couldn't find anything. Ain't that fun? And then started researching, how do these things work? I knew that that they had their own control board basically managing them. Well, this one doesn't seem to have that. So this little sensor right here has direct connections from its legs to these wires. So basically these fans are as dumb as they get, and they were controlled remotely by a PCB or whatnot. Let me show you one of their connectors. This is how their connectors looked like. Yeah, fun and games. Now, because I didn't find online a datasheet for this thing, I'm not sure if I'm actually able to use it in some kind of direct mode where itself is the controller that gives the impulses at the exact right time to maintain and initiate and maintain the spinning of the fan. I have no clue if I can do that. There are controllers like this that are a bit bigger and have 4 legs, and they actually control that thing. There are even 3-legged ones that control this, but the order of the legs, where you need to give it ground power and where you take the power from it, or for some of them they give so small of a power in here, you need to have a second transistor or something to do the further driving. So I have no clue the pinout for this and if it's actually able to control the whole thing. I'm going to basically do some tests with various configurations of the wires, see if it works. If it doesn't, well, there's that. I'll see what I'll do next. But overall, this is as dumb as it gets, and it's just not made to work by itself. I did all the possible connections. Let me show you my logic here. So that chip, as far as I understand it, the 3-pin needs to have ground and a power, and it will either give a weak signal for other electronics to transform it into something stronger, or directly give a strong enough signal for a motor to turn. So ground, I gave it into the chip, as far as I think, and to one of the end of the winding on the motor. Then I connected this, which is the yellow one, the other end of the winding, taking turns with the wires, and gave the chip 24 volts basically, and maximum 0.3 amps. That should be in line with about 8 watts that this should draw. Nope, nothing. And you are looking at nice colors, red to red, black to black and blue. Believe me, I tried reverse polarity and I tried every single wire combination, with this having one on one side, 2 in here, and another wire connected to yellow. If I have the understanding wrong about how this should operate, then yeah, that's the problem. Otherwise, this just needed external electronics to control it, and it's just not able to operate based only on that sensor inside of it. Maybe it's the variant that gives just a really weak, a few milliamp signal, which is obviously not enough to turn this. So now what I'm doing next, because it's unusable for me anyway, I will bump up the amps from 0.3 to 0.6. Maybe it needs a bit more juice when it starts turning. If that helps, okay. If not, at least maybe I see some smoke and I know that I'm done with this. It's attempting to do something, but nope. And even more magic smoke. But what I can say for sure, thanks PicTech for this. I could play around with it a lot, and until I went to this 600 milliamps, no magic smoke appeared. So this gives you the opportunity to test stupid things a little bit safer first. But no, this had no chance. This fan, I don't think it was ever built to operate on its own without being externally fully controlled. Here we have a proper fan. Let's not short these wires. And let's see, 12 volts. This is a 24 volt, so we are giving it low power, running as a champ. In theory it should draw 0.1, and it's drawing way less at 12 volt. Let's play with it. You can hear it ramping up. Still not 0.1 amps. Outputting a fair amount of air. I will test it with another PicTech tool in a second. Changed the limit of the current a bit more, but this is still not drawing more. Obviously it was not at the limit, but just wanted to make sure this is not a limiting factor. So at this point let me do an airspeed test. This is kind of a dumb test. The fan has a weird cone, and in the middle it's not outputting that much air. I'm trying to keep about this much distance, which is about 20 centimeters more or less, and I will move the fan at that particular distance to see what value I get maximum. So it's 1.3, 1.4 meter per second, and I'm not going closer with it because that would just change the results. I'm just moving it around and making sure I am getting in the cone of the fan to the max possible. And I think 1.4 was as high as we could get. What you are about to witness is really dumb, but sometimes dumb is my middle name, or my first name, or all of the name, whatever. I don't care. Sometimes I just need to roll with it. I'm going to remove everything from this because it's basically useless to me. I just need the case itself to be still holding together when I'm done with it. So I need a bit more destruction force. Yeah, I need to bring in some bigger tools and start chipping away at this, because there's no other way for what I want to do here. This will not be thrown away, don't get me wrong. I will reuse the bearings probably in other projects. I will probably reuse the wires in the coils. Doesn't want to come out, and I don't want to damage the housing, so I will Dremel around this area so everything in the middle falls out, because it's just pressed onto the middle. You can see the edge right there from the plastic of the coils and the rest of it, but doesn't want to come out, so Dremeling, but not on camera. And voila, this is out, and again I will reuse the wires and bearings if needed at any point in time. And now I just need to clean up this a little bit, and I have my case. This is good. Next step, let's see what we can do with this thingy. As far as I remember, the magnets in this kind of fans are like kind of rubber. They are kind of soft. You can hear it. It's not a really strong material, but this is a bit stronger than what I'm used to. And then again, I really want to reuse this, so not destroy it. And now that I've weakened it a bit, slowly, to not destroy the plastic, I'm going to get rid of this magnet, as you can see. If I can remove it mostly in one piece, it's great. And in here I think we have a metal ring. I might be able to go deeper. This is still really heavy. all of this is actually metal, as you can see by this lip. And I think you see those, they are just heated and melted over the metal. So if I remove them, probably I will be able to somehow get this metal out, maybe by tapping it in here. I just don't need to damage the plastic itself. Be very gentle with the plastic, not with the metal. Now hopefully just a little bit of gentle persuasion with a hammer will do the trick. Went easier than expected. Basically put this on top of it, put this on my legs, so it kind of had support all around, but the metal had still a bit of a way to go. So put it like that, gently tap it 2 or 3 times, and this heavy thing is out. So now we have this plastic which is super light. Basically we are back to almost having a fan, 12 millimeter. Now let's cannibalize this one, the 12 millimeter, 12 centimeter, the 8 centimeter one, which you will say probably some of you, why destroy it? I got it for free from a printer that was actually a fax machine, I think, that somebody gave me. It was basically e-waste, and I salvaged this, and I don't really have anything to do with I cannot really talk today, with a 8 centimeter fan, but as you know, I need a bigger one. So at this point, snippety snip snip, and we'll probably be gluing this on top of this, and the motor will be going inside of this base. Make sense? I hope. Okay, break the fins. They were not that easy to break. Again, I could have just bought another fan, but where's the fun in that? And now I can also actually reuse the motor from this. And as you can see, this has a 4-leg driver inside of it, which is doing all of the heavy work. So there's that. Made a bit more progress. Cut these legs even more, grind it down what remained of the blades. It can stay in here, and this on top, but we have a problem. The blades seem to be hitting this, because this was a bit deeper, the big one. Or are the blades not hitting? Not yet. I think in the middle we are hitting plastic on plastic. Let me see what's the gap in here. Basically almost nothing. So I think if I remove this edge just a tiny bit, come closer to the blades, we will not have contact anymore. Just a tiny bit. Okay, degreased all of this, this also, and this. Because I removed all of this weight, why not put some of it back? Anyway, the idea is that I do need a spacer just to make sure that nothing will touch in here, so I will glue this spacer right in there with super glue, basically. This on top of it. Luckily I have that hole in the middle that I can line with this in the middle to make sure that everything is in place. And once this is dried up, I will glue everything in here, because I also want to align it, making sure that it's where it should be compared to the edge of it. So yeah, at least that's the plan. We'll see how everything goes. I'm quite curious if it will make a faster air movement, or at least if I feel more air, or I just made it 12 centimeters and still as slow as it was before. Who knows? Putting a ton of glue on everything. I'm going to spread it around as best as I can, and then stick them together, make sure they are centered as best as I can, and hope they last. But in theory they should last. I don't see any forces that can take this apart, if I don't count on human intervention, obviously. So natural forces, let's say like that. At this point I'm letting it dry up with a weight centered on it as best as I could. It's centered also like this. So in theory all good. After this dries up, next step is that one. And this is dried up. Yes, being super glue, it leaves a lot of this whitish residue. Don't really care about it. I will inject a bit more glue through that hole, and my phone stopped recording because the battery is drained. Now I want to put glue on this and on this and smack them together and make sure the wires go through the proper wire area right there, so we don't have any problems, and then just make sure everything is properly centered in here so we don't have scraping or any collisions or whatnot. As you can see, used a ton of gel super glue in here, some also on the wires in that area so they cannot rip out. I will put a zip tie in here on the wires. It's exactly as it was from factory with a zip tie. Doesn't touch the blades, they are not anywhere close. Now we have a gap in here from our washer spacer in there. This is centered. Also put some glue right there in the middle to fill that hole and make sure everything is even better glued. So in theory this works perfectly. Now we just need to let it dry, and I'm going to put it again on top of something because super glue, as you know, will leave this whitish residue, and I kind of don't want that all over my workbench. And now another heavy weight in here, another big socket, and let it dry for a few days maybe, just to make sure, because there's a lot of glue in there. And we are going to let it dry now. Continuing to convert the second motor, and just an update. I tested the flammability of this thing, and literally you can not burn it unless you keep a flame on it. The second you take it away, it self-extinguishes. So maybe all fans have such a material in them. Tried also on the material of the big fan itself that we have here. Exactly the same situation. It will not burn by itself. Only if you keep an open flame directly to it, the second you pull it away, it extinguishes. Which is perfect. So they are a bit safer than I was expecting. If I didn't mention, I could not just connect the electronics from this one, even if I would replace sensors and do lots of hacking, to say like that, because this is a 2 connections motor. So it has just 2 ends for the coils, one here and one here. This has 3. So the driver is not the same for both of these. It would be impossible, and again, this was not a driver, this was just a Hall effect sensor, and the driving was being done by a completely different board. So my only way was to hack them like this. Hopefully you can see everything. Let me rotate the fan because it will blow air towards us and probably affect the video, the sound of it. Let me just check something with my hand at least. Wait a second. Why is this rotating in reverse? Oh no. Oh no 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 no. Were just these 2 fans actually in different directions? Oh no, please no. That would basically suck. This is rotating backwards. Whew. Okay, be back in a second. My plans got destroyed. You see it? They rotate in the wrong direction. So basically my new big fan now rotates like this, and that's not good. It should be rotating like this. Now what I'm going to attempt to do, open up this little guy, because it's easier to work with a non-modified fan, and see if I can make it rotate the other way around. And if I can, I will also open up this big guy and make it rotate in the proper direction. That's gonna be fun, isn't it? I present you the modified fans. This is fan number 1, this is fan number 2. They were almost identical, same brand, same power mostly, but the driving chips inside of them are not identical. Now, just because we can, a quick test. Yes, this will be upside down. 2.5 meters per second. Let's go at the other side. 2.1 to 4.5. Let's get it here. 2.5, 2.4. So they are about the same, both of them. Now let's check at that weird distance like I did before to see if a bigger fan gives us a little bit more airspeed, not volume, speed. Okay, same situation, about this distance, which is about 20 centimeters. Power this thingy on, and fan will be getting the 24 volts as before. Oh, we are getting basically nothing. We saw 1.1.4, 1.5, 1.6. So right smack in the middle, this fan is not really moving that much air because it has this huge thing right here, being a bigger fan. And this is the power draw for fan number 1. Let's check fan number 2. Fan number 2 is drawing less power. Let's give them another power on. Quite quick power on. Lower the voltage. 16, 12, 8 volts. Let's see which one of them stops first. But yeah, overall, I consider this a success. Not perfect, but it's doing what it needs to do. 6 volts. 5 volts. Way under the normal voltage for these things. 4 volts. Come on, are you not stopping? 3? 2. At 2 volts you should stop. And which is the first? It's the second one. So the first one that I modified is actually working at 2 volts. Let's increase to 5. Almost powering on. Nope. 7. Nope. 10. Nope. 14 volts, and it will power on. And it's on. And that is also much lower than its normal working speed. So, hope this video helps you, in which case please give it a like, check out my other videos, and as always, see you in the next one. Bye.